Good morning, students. Now we are going to take a very important topics. We say differential equation. Differential equation is a very important in scoring topic of class 12th examination point of view. We bifurcate. We participate it into three major parts. First of all, order. Second, degree, and third, solution. We take step by step all these aspects in our video. Please join this video till the last moments. First of all, order. Differential equation, order of the differential equation is that the highest derivative of equation, we say the order of the differential equations. For example, we take a differential equation d3y upon dx3 to the power 4 is equal to 4 plus dy by dx to the power 3. For example, we take a differential equation d3y upon dx3 to the power 4. D3y upon dx is nothing but a third derivative of y with respect to x. And here is power 4 is equal to 4 plus dy by dx to the power 3. According to the definition of order, we see that the highest derivative in occurring in this differential equation is a order of this differential equation. We say the order of differential equation is a highest degree, highest order of the derivatives. Here we see that highest order is 3. Then we say that the order of this differential equation is 3. Order of this differential equation is equal to 3. Now we come to the degree. Degree is highest power of the highest order occurring in this differential equations. We see that highest order of the differential equation is 3 and power is 4. Then we say that the degree of differential equation is 4. Order is 3 and degree is 4. This question is very important for objective types of questions as well as the major questions, differential equations part. Now we come to the very important aspects of this topic. We say solution of the differential equation. Solution of differential equations. Solution of differential equations contains three parts in the syllabus of class 12th. First of all, separable variable. Separations of variable. Second part is homogeneous equations and third is linear equations. We come to all the type of equations and their solutions step by step. Now we take example dy by dx is equal to 1 minus cos x upon 1 plus cos x. For example, we say that here is a question, solve the differential equation dy by dx is equal to 1 minus cos x upon 1 plus cos x. First of all, we assure that what is the type of this differential equations. We see that differential equation is the type of dy by dx is equal to fxy. So it is clear that firstly we have to separate the variables. This type of questions will be fx dx is equal to gy dy, and then we have to integrate fx dx is integral to gy dy. This is the working rule of this type of differential equations. dy by dx is equal to fxy, which contain x and y, two variables. We have to participate, we have to separate its variable. Fx dx is equal to gy dy, and then we have to integrate this both the sides. Integration of fx dx and is equal to integration of gy dy. Now we come to our question. dy by dx is equal to 1 minus cos x upon 1 plus cos x. We have to solve this differential equation. First of all, we have to separate the variables because the variables are separable. One minus dy by dx is equal to 1 minus cos x upon 1 plus cos x. Then dy is equal to 1 minus cos x upon 1 plus cos x dx. Very easy. Firstly, we have separate the variable of the differential equations. 1 minus cos x upon 1 plus cos x dx in right hand side and dy in our left hand side. According to working rule, we have to integrate both the sides. Integration dy is equal to 1 minus cos x upon 1 plus cos x dx. Integration dy is equal to integration dy, then we can write this left hand side in the form integration 1 dy is equal to integration 1 minus. Here is the formula of trigonometric cos of 2 theta. Cos of 2 theta is equal to 1 minus 2 sin square theta, half angle formula, and 2 cos square theta minus 1. But in our question we see that here cos x in place of cos 2x. Then we can return cos x in the form 1 minus 2 sin square x by 2 and 2 cos square x by 2 minus 1. So substitute 1 minus 2 sin square x by 2 in place of cos x and 2 cos square x by 2 minus 1 in place of cos x. We find 2 sin square x by 2, 1 plus 2 cos square x by 2 minus 1 dx. Integration of 1 dy, integration of 1 is y and 1 minus 1 plus 2 sin square x by 2 upon 1 plus 2 cos square x by 2 minus 1. 1 to 1 cancel, 1 to 1 cancel, dx again 2 cancel, y is equal to integration sin square x by 2 upon cos square x by 2. Is that tan square x by 2? Tan square x by 2 dx. Now we see that tan square x by 2 can be written as sec square x by 2 minus 1. So we can write y is equal to integration of sec square x by 2 minus 1 dx, and y is equal to integration of sec square x by 2 dx minus integration of 1 dx. Again y is equal to sec square x by 2. What is the integration of sec square x by 2? Tan x by 2 and the coefficient is 1 by 2. Then here we find tan x by 2, tan x by 2 upon 1 by 2 minus integration of 1 x, and because this is indefinite integral, then we have some constant c. We can easily write this step in this form: y is equal to 2 tan x by 2 minus x plus c, and y is equal to 2 tan x by 2 minus x plus c is the required solution of this differential equation, which is variable of separation of variable. Here variable are separable. Now y is equal to 2 tan x by 2 minus x plus c. According to definition, what is the solution of this differential equation? Solution is that when we put this solution y is equal to 2 tan x by 2 minus x plus c in our differential equation, then we find satisfied this differential equation or identity. Now again, please take a screenshot of this solution. Again we come to our next question. Solve the differential equation e to the power x plus e to the power minus x dy minus e to the power x minus e to the power minus x dx is equal to 0. Similarly, we solve this differential equation in same manner we see in the previous question. Very easy. First of all, we have to separate the variables. Now we come to our question. E to the power x plus e to the power minus x dy minus e to the power x minus e to the power minus x dx is equal to 0. By transformation, we get e to the power x minus e to the power minus x dy is equal to e to the power x minus e to the power minus x dx. Again, dy is equal to e to the power minus x minus e to the power minus x upon e to the power x minus e to the power minus x into dx. In this step, we can easily find that here variables are separated. E to the power x, variable x in our right hand side and y in our left hand side. Now we integrate both the sides. Integration of 1 dy is equal to y and e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x dx. Here we see that the differentiation of denominator is exist in the numerator. So then we see what is the form of this integrand. Integration of f dash x upon fx dx is equal to log of fx plus c. Differentiation of denominator is exist in this question on numerator. Then we can easily write this step. Integration of f dash x upon fx dx is equal to log of fx plus c. Directly we can use this formula. Log of e to the power x plus e to the power minus x plus c. We know that c can be written as log of c. Then we find y is equal to log of e to the power x plus e to the power minus x plus log of c. Y is equal to log of e to the power x plus e to the power minus x into c. This is the required solution of this differential equation. And when we put this value of y solution of this equation in our basic fundamental question, e to the power x plus minus x dy minus e to the power x minus e to the power minus x dx is 0, it satisfied this differential equation, or we can find a identity. Now this is our first type of differential equation, says separable variable. In this type of differential equations, we see that when we separate the variables and in the next step we integrate this integration of this integrand, we find the required solutions. Again, we come to the second type of differential equation, we say homogeneous equation. Homogeneous equation. Homogeneous equation is in the form dy by dx is equal to fxy upon gxy. Fxy upon gx, numerator is of the function contain variable xy, and denominator is function gxy contain xy, but here is the necessary and sufficient condition is that the power of the variables will be equal, and we say homogeneous equations. For example, we take dy by dx is equal to x cube plus y cube upon x square y. Here we see that the power of numerator of variables is 3 and denominator is also 3. 2 and 1, 2 plus 1, 3. So this equation is termed homogeneous equations, and we have to change it into form of separable variable. And what is the method? Method is that we have to put y is equal to vx in this type of differential equation. Y is equal to vx. When we differentiate it with respect to x, we find dy by dx is equal to v plus x dv by dx. This is the easy trick. When we have to given this type of homogeneous equations, first of all we have to put y is equal to vx in the right hand side of this equation, and when we put y is equal to vx and dy by dx is equal to v plus x dv by dx, again by transformations we find the equations is in the form of separable variables. Then the method will be remain same in our previous question. So here is the homogeneous equations, and third type of the differential equations is linear equations. Now we discuss in shortly what is the linear equations. Linear equation is of the form dy by dx plus py is equal to q. When what is the p and q? P and q is are constant or function of x. Function of x. And what is the solution of these equations? Solution of equation is y into integrating factor is integration q into integrating factor plus c. Here is the formula for find the solution of this linear equation dy by dx plus py is equal to q, and p and q are either constant or function of x. But here a very important term, integrating factor. What is the integrating factor? Integrating factor is e to the power integration p dx. So when we given this type of linear equation, firstly we have to evaluate integrating factor. Integrating factor is equal to e to the power integration p dx. Then put the integrating factor in this formula, y dot e integrating factor is equal to integration q into integration factor, and when we integrate right hand side we find its required solution. So in this video we have discussed order of the differential equation, what is the differential equations, degree of the differential equations, solution of differential equation, what is the definition of differential equation, and which are the types of differential equation, and what is in which manner we can solve these differential equations. First of all we have the separable variable, second homogeneous equations, and third is linear equations. In our next video we will surely meet with new fundamental things. Jai Hind, Jai Bharat.